Hello, this is Dr. Bahauddin Abdullah. I'm going to continue section 9.5 in this video, Determinants and Cramer's rule. And here I'd like to talk about how do we use Cramer's rule to figure out whether the system is dependent or inconsistent. So that's the method. If all the determinants is 0, it's a dependent system, and we have infinitely many solutions. But if D is 0, which is in the denominator, and any of these, at least one of these is not 0, then it is immediately inconsistent system. You can have more than one of them different than 0. So for example, this is a system. To solve this system using Cramer's rule, I have to write it in standard position. So I'll take 3y to the other side and 2x to the other side, and I write it in this way. That's the standard position. Now this would be D, 3, 2, 3, 2, it is 0. dx would be, replace the first column by 2, 3, it is negative 2. dy would be, replace the second column of D by 2, 3, it would be 5. These two are different than 0. D is 0, so the system is inconsistent. While in this example, second example, also again write it in standard form, x, y, constant term. Now D would be coefficients of x, coefficients of y, 0. Now dx, replace 3/6 by 1632, it is 0. dy, replace 4/8 by 1632, it is again 0. All of them are zeros, so the system is dependent, and there are infinitely many solutions of this system. Let us denote the minor of Aij by capital Mij. We said the minor is when you remove the column and the row. So here you remove row I, column j to get the minor of Ij. The cofactor of Aij would be, let us denote by Cij, capital Cij. It is the minor, but multiplied by negative 1 times I plus j. So if I plus j is even, it would be exactly the minor, but if I plus j is odd, it would be negative the minor. So let us see this example here. This is a matrix A, 4 by 4 matrix, and we have 3 questions. Let us find M23, the minor of 2, 3. So go to the second row, third column. So it's this number 5. And the question, what is the minor of 5? Remove the row and the column of 5, you get this matrix or this determinant. Find this determinant using the definition of 3 by 3. I will expand this determinant using the first column. So 0, خلاص 0, there is no need to write it. And the sign here is negative, so negative. The minor of 1 is 4, negative 3, 0, 1. The determinant is the minor. Plus 3 times, okay, the minor. So it is 50. So that's the minor of 5. It is 50. Now what about the cofactor of 5? It is the same as the minor, multiplied by negative 1 to the power 2 plus 3. 2 plus 3 is 5, so this is negative 1. So the cofactor of 5 is negative 50. Now, how to find the determinant of A? Well, to find the determinant of A, I will expand using this column because it has 3 zeros. So I only have 5. Multiply 5 by its cofactor to get the determinant. So the cofactor is negative 50. So the determinant is negative 250. So if you have a 3 by 3 matrix, to find the determinant of the matrix, it's really multiplying A1 by the cofactor of A1 plus A2 by the cofactor of 2, 1 plus A3 by the cofactor of 3, 1. If you use the cofactor, there will be no need for negative signs because it's taking care in the definition of the cofactor. But if you use the minors, then there would be a negative sign somewhere here in the middle, if you remember. Now, if you write the matrix A in this form, and usually we write it like this, A11, A12, where 1, 3 means the first row, the third column. So the determinant of A can be written like this. If you expand using the first column, it would be A11 times C11, the cofactor, A21 times C21, A31 times C31, or you can choose to use the first row. So it would be A11 times C11, A12 times C12, A13 times C13, or you can choose any other row or column. Just multiply each number by its cofactor to get the determinant of A of any order, 3 by 3, 4 by 4, or 5 by 5, or higher. Good luck.